Stéphane Chenard with Euroconsult in Paris. We're happy that you can join us today for this event in association with Connectivity Business News. Thank you to the sponsors of today's webinar, the creators of the new online training material for those in the space and satellite industry, Space Business Qualified. These courses are a great way to onboard new staff, broaden knowledge of existing staff, and prepare staff for increased responsibilities. It's all about staff. Additional information is at spacebq.org, BQ Bravo Quebec, in one word. With that, let me introduce today's panelists. With us are Albi Besta, Market Development Manager at Intelsat, Carl Horn, Vice President of Cloud Solutions at SES, Stuart Drottridge, Vice President of Advanced Technology at Kratos, Sean Yarbrough, Vice President of Product Management at ST Engineering iDirect. So welcome all. So in the 1960s, where am I going with this? You might think one vision for the future of computing was that we would all share time and computing with big centralized mainframes. What happened is that PCs came along and the big obsolete big iron centralized company vision was dismissed as really yesterday's thinking. Then about 15 years ago, the PCs reached their limits, and now we are all sharing time and computing power in big centralized server farms, which the IT industry, since occasionally it likes its jargon to be playful and obscure, took to calling the cloud. So there's nothing fluffy about the infrastructure we're talking about. And of course, this is precisely the cloud what we are using today with this video application that we are using. But transport is evidently a major part of how the cloud works, and as such, where satellites fit in the picture has been a topic of great strategic importance to the industry for a while, and that is what we will discuss today. So just to set the scene, let me ask all of you, after maybe a few words of introduction about your companies, if in case anyone in the audience is not intimate with us, what has driven the satellite industry and the cloud industry together, and why now? And is it easy or is it difficult? Who wants to start? Carl, you are okay.
Yeah, sure. So I guess first, good day to everybody for wherever you are in the world. I'm Carl Horn from SES, and just as a brief introduction to SES, we operate one of the largest fleets of data service satellites in the world. We were one of the first to offer a multi-orbit fleet with geosynchronous and medium Earth orbit satellites. We really see the power of medium Earth orbit fitting really well for the topic of today. In terms of interconnecting the cloud, but in our next generation system, also leveraging some of the virtualization concepts that we'll talk about today. So very, very happy to be here with you today. So what factors maybe have contributed to the satellite industry now looking at cloud and cloud adoption? There are multiples, of course. I'd probably highlight three. I mean, I think the first one is cloud service providers themselves are embracing space strategies more directly. Several goals in mind for them. Key amongst those is expanding the reach of their cloud services and growing their subscriber base. That's ultimately how they make money. So in support of that, some of them are launching fleets. Some of them are establishing key partnerships with space operators like SES. And additionally, they're launching and devising new services that are intended for satellite operators, ground stations as a service, et cetera. So that's, I think, one of the first factors that the cloud service providers are really stepping into this space. Second factor, which we'll talk more about today, is that the satellite communications is moving much more towards cloud native architectures. And so I think there's a pretty natural alignment of cloud and space infrastructure. So it's creating some previously unexploited ecosystem partnerships. But the third factor, maybe even the most significant one, I think, is these are new cloud-based service delivery models. These are starting to emerge now to better serve the SATCOM end users, which themselves, they're leveraging cloud services and virtualized functions. So many more synergies are possible now. So again, there are, I think, many factors, but I'd certainly highlight those three.
Thanks. And yes, there are two aspects to the discussion that, and we will touch this in sequence. There's cloud, there's satellites, and the cloud ecosystem, but also there's the cloud-based tools and how they are used by the satellite industry for its internal processes. So we'll touch both of those. Stuart, Sean, your thoughts on this?
I think Stu was on.
Yeah, please, everybody.
Yep. Sorry about that. So I'm Stuart Daughtridge. I'm from Kratos, and we do satellite ground systems, everything from antennas all the way back to command and control systems, modems, signal processing. You know, one of our big focuses over the last several years is, you know, moving toward the digital transformation of the industry. And so this is a really interesting topic for us. And, you know, I agree with everything Carl said, and I'll give my three factors, but they're sort of sub-factors to some of the ones Carl mentioned. So the three factors I would say that driving adoption is, one, is that the new space market already started this adoption for the satellite industry. You know, new space satellite companies came along, dramatically reduced the cost of satellites, forcing a new approach to ground systems to be considered. So it forced the satellite industry to start looking at ground systems and start adopting and embracing some modern IT concepts, including virtualization, cloud computing, to reduce the infrastructure costs and to enable greater scale and deliver what that market really needed. And out of that came the entire ground system as a service market that supports the you know, Earth observation market today. And that in turn, actually, I think attracted the cloud industry giants, you know, to the satellite industry, namely Azure and AWS. I'd say the second reason that, you know, the reason for cloud now in the satellite industry is the satellite payloads. You know, the Ultra HTS satellites and the LEO MEO constellations that are now, you know, starting to be developed and launched. They have a similar problem that new space market had, you know, 5 years ago. And that is with the massive growth in bandwidth and capabilities these systems deliver. It's way too expensive with the legacy architectures to scale to the levels that these ground systems now need to support. And so new approaches are needed for the ground for these systems, and cloud and its related technologies of virtualization, software-defined networking, orchestration, zero trust cybersecurity architectures are the only ways to really provide the level of automation and scale that the SATCOM industry is going to need in its future ground systems. And then I'd say the third reason now is the right time for the industry is the industry starting to recognize the need for the adoption of open standards, whether they're from the telecom industries like MEF and 3GPP, or from the satellite industry like Diffie. The satellite industry of recognizing that it's better to be part of the larger telecom ecosystem than to be sort of a special niche capability. So I think all three of these factors, new space adoption, next generation satellite payloads and constellations and standards are all helping to push the satellite telecom industry towards the adoption of cloud and cloud related technologies.
Well, exactly. I think that the satellite industry came close to being buried in its niche actually a few years ago, but it's not like we have a choice about using the cloud either, because like you said, we've reached a point where what we want to do has to be done on a hyperscale sort of architecture. The satellite industry, the EO industry, for instance, uses a lot of artificial intelligence. Can that work without big cloud server farms? And also, I think it took a while before everybody understood what we're talking about. Sean, your input
Absolutely.
on this.
Absolutely. I mean, so welcome everyone. Good morning. I'm Sean Yarborough from STI Direct. We are a ground infrastructure provider also. So actually SCS and Intelsat are two of our largest customers. and we're excited to be here to talk about this topic. As Stefan is saying, there's a lot of advantages, and everyone on the panel is saying there's a lot of advantages towards moving to the cloud. A lot of it is very much customer driven, right? So you talk about the capacity that these new satellites have, the capacity or the throughput demands of customers are driving more processing requirements. And when you think about scale, the cloud delivers you scale in the most efficient way to do that. But another one is really this transformation in terms of how we offer our solutions. So as a ground infrastructure provider, we provide modems, we provide network management systems, we obviously provide the modulation and demodulation, but those costs are traditionally very CapEx intensive. When you're looking at brand new service offerings that may be anywhere in the globe, being able to really align your cost from an OpEx perspective versus CapEx to your revenue is also advantageous to the market. And so we see cloud as another way of enabling us to change our business model for customers who need it, to enable them to have a global presence even faster without necessarily spending as much CapEx upfront. And the last piece of that is around availability. Today, again, you're talking about global customers. So you have customs, import, export, VAT duties and things of that nature, shipping times that delay servers and hardware from being deployed. When you're deploying things in the cloud or public or private cloud, in that case, on COTS hardware, it enables you to get your solutions up to market, your services up to market, and reduce your time to revenue or increase your time to revenue by moving to the cloud. And so on top of all the things around security, scale, and what was the other one? I think someone else mentioned earlier. Also the analytics on top of the cloud. I think those are also very important. The analytics to me is a third of value add. So once you have this processing capability in the cloud, partners like AWS and Azure have these value added applications that only enhance the overall service offering to our customers, whether it's firewall, whether it's advanced AI or other applications. And so it's exciting to be able to leverage that along with our traditional ground infrastructure to bring new services to market faster.
And Albie from Intelsat.
Yeah, Albie Bester here, Market Development Manager. So Intelsat, today we operate in a region of 55 geostationary satellites. So that is sort of our historic business going forward. In our future, we're planning a unified network, which really will become the network of networks. And that is pretty much cloud end to end. So software-defined satellites, software-defined terminals, software-defined network end to end. And just thinking of the question, so how is it that the cloud only reaches, or how does that satellite and cloud only meet each other at this stage? I was just looking earlier, I wrote my first cloud strategy plan 13 years ago for Microsoft South Africa. And basically it was it was called BPOS before Office 365. And it was consumer products, the consumer services. So if we look at the cloud adoption, it started where all the users were, or the users typically are. If we roll forward, I mean, it's only in 2020 that AWS came out with AWS Ground Station and Microsoft Azure with Orbital. So it took a while for the industry to catch up and for the services to be made available that are cloud ready. But for us, at the north side of our business, cloud is going to be entrenched in it end to end from gateways and from terminals. And at the south side of our business, I mean, cloud is part of our strategy, edge compute, taking it to the enterprise, in the industrial IoT running on edge computing. So that's all part of a cloud strategy.
So it took a while, but are we happy with the mutual understanding between the satellite community, which has its traditions, its technologies, is mainly about transport on this side, and the cloud industry on that side, which is very large companies that are used to getting things their way, and which are in different layers in the telecom and IT architecture? Do we all understand each other, or are there still any convergence that has to be achieved? Albie, you seem to say that no, it's we're there now. You do come from the cloud industry, as you said. Does everybody agree, or do we still have some work ahead of us?
I would say I would agree with that also. I think that convergence is already happening in a very positive way. I think the satellite industry is embracing the cloud, and the cloud industry is embracing satellite industry. And you can see that through the partnerships and some of the kind of early initiatives. Someone mentioned earlier the Diffie initiative. I mean, that's a combination of satellite operator or satellite industry participants and cloud coming together and saying, how do we develop standards to make this happen? So to me, that collaboration and that convergence is happening. It's probably not happening as fast as we all would want it to happen, but the intentions are there. And again, the standardizations are moving in that direction. A lot of the proof of concepts that we've been doing with some of our partners are very, very positive in terms of convergence.
Let me touch on one aspect of the relationship between the satellite world and the cloud community, which I think is topmost and among has been topmost in the discussion so far. It's latency. It was common wisdom that a lot of cloud applications couldn't work with geostationary satellite latencies. Microsoft has documents out there that explain that if you run Skype for Business, for instance, it doesn't work if you have more than 100 milliseconds of latency, and it's there black and white in what they tell their customers. Is it true? Have we gotten around the latency issue? It's obviously a little bit more nuanced than that. We're not, I think, at the point of 5 years, 10 years ago when people said, nah, satellites don't work at all. That there are some things that work, some things that work less well, some things for which you need to have maybe a non-geostationary system to play the game, and other aspects of cloud services that are indifferent to the latency. Surely now we have examined every angle of that question. Who wants to take that up? Albie.
Yeah, I think I agree. If you look at the specifications or what will work and what won't work, I found it very interesting. Earlier this year, we ran a private LTE network across our satellite network, working with Microsoft Azure and the Fusion LTE core. And we fired up team sessions, streaming video across the team sessions. I had a number of users. I had one of the users running a video on her computer or his computer, showing it to all of the others. So certain applications will definitely be more prone to latency sensitivity. But I think it's more and more we'll see into applications becoming intelligent and be able to handle the different layers of the cloud, especially if we start looking at edge compute and pushing the cloud to the edge. Many applications will work very, very happily at that edge. And some applications, like you said, like Teams, maybe if you're going to have 100 users, we haven't tested at 100 users. We will be testing a private 5G network pretty soon, and we'll see how many users we can add up before it falls down. And well, falling down, it was a 10 by 3 megabit network on LTE, so it wasn't even a fast network.
Well, you can hardly tell your community of customers that some things will work, but expect some don't, that some won't. True, it's tricky to manage, no?
I think you need to classify what will work and what won't work, and what are the workarounds if it doesn't work. So if you look at email, if you look at your offline caching, or if you look at your Exchange offline folders, some of those things are taken care of with a low latency network or higher latency network.
Carl.
Yeah, so I certainly agree with Albie on that. Just wanted to add a comment if I could here. So I agree, historically, there's been a lot of focus on satellite latency, and it's been seen as a penalty or a detriment. And to be honest, I see it changing when we start thinking about the full end-to-end service path from user to cloud. So I just wanted to mention, we've been doing some benchmarking tests. This is over our MEO fleet at SES. They're showing that the overall end-to-end latency of MEO versus even fiber between the Middle East and Europe really increases only fractionally, like around 45 milliseconds or so, when you're considering the full user to cloud path. So it's not just the satellite hop, it's everything else that's on either end of it. And it kind of shows that a satellite enabled single hop, if you will, can offset a lot of terrestrial router transit latency. So when you couple that with some of what Albie's been saying, with more distributed cloud architectures, including edge compute, And I think we're really starting to obviate the latency question as an industry.
We have a question that just came in from the audience, and I think it's interesting. It's obviously inspired by very recent events. We're starting to see some critical infrastructure sabotaged, and I'm sure this brings up the question of satellites as backups, as helping the resiliency of architecture. It's nothing new for the industry, but if it's cloud-based, then push of a button, bing, I can redirect my traffic around places where somebody blew up the cable, right? Tell us if it's that easy, if you can do this without the cloud, how much your implementations of cloud technology allow you to do that, and also how much your phones are ringing from various places and your government customers may be asking precisely that question. Albie and then Sean.
I think Sean is actually before me.
Yeah, Sean and then Albie. Yeah, you're right.
Yep, no worries. So yeah, great question, actually. And so probably I would answer this two ways. One is, you know, the resiliency and redundancy of our networks is not dependent upon the cloud. I think the cloud enhances our ability to do that. So we have solutions and customers today who have redundant or backup gateways and backup hubs to enable to really avoid the situation you're describing, Stefan, where obviously there's a mistake that happens or there's actually an attack in one gateway. It can automatically switch over to a secondary gateway and keep service up and running. That's there today. I think what the cloud does is enable us to deliver that more efficiently and globally in a way that you know, dedicated hardware, dedicated data centers would not allow you to scale that, right? So when you're talking about a few hubs or a few gateways, you can manage that as an individual provider. When you start looking at the scale required for some of the LEO, MEO constellations in terms of ground infrastructure, you're going to want to consolidate that in more places around the world. So I think cloud allows us to give that scale with more efficiency. But our networks today already have that redundancy from a geo perspective, high availability perspective, supported.
And Albie, I do want very much to hear you on this question, but and my script goes out of the window because we were going to examine those questions more toward the end. But Sean, you just said, yeah, we can do all that anyway, redirect traffic and reconfigure networks. We can just be more efficient with cloud-based architectures. Now, what's changing exactly? Because this implies that the old way of reconfiguring the network includes people putting on hard hats, going down to the basement of the satellite operator and changing, swapping IRUs in racks, pulling levers, replacing lamps, and doing all sorts of manual processes, which I think the satellite industry being a very high-tech industry, you don't expect that there's a lot of manual processes, that everything, you know, in my imagination at least, was push button. No, there's a lot of crawling under the table to unplug and replug. So Albie, tell us your take on all this, and also maybe contrast with the way it's done now, the way it was done before.
Yeah, I must say, I joined the satellite industry in 2016 after, I think, 20 or 25 years in the IT industry and cloud. And I was blown away, or I was shocked that there was so much hardware that had to be the proprietary hardware, and everything is a piece of hardware that needs to be installed somewhere and configured and then shipped. And so exactly what you were saying is the moment we start abstracting all of these services, even from a gateway side or from a terminal side, we start abstracting these services and run them as either on VMs or containers or whatever, then it becomes the whole remote configuration becomes very possible. So the example we're using this private 5G network, or the private 5G multi-access edge compute we're busy building, it runs on Microsoft Azure Stack Edge. And some of the people that does the configuration for us sits in Italy. So now really it becomes the moment you can, as long as you can connect to the device and that device runs the services, that's it, no more crawling around.
And Stuart, I think you wanted to address the flexibility on virtual aspects of virtualization.
Well, I just want to add something to what Albie said. It not only changes the configuration and the deployment time and all that, it also helps change the economics. Because now you don't have a piece of hardware that you had to pay for in advance sitting out there and needing to be there so that when you have the failure or you have the attack, you can turn this on. All you need is to have some generic compute out there, and basically then you spin up the software licenses when you need them. And that economically changes the value proposition to the end customers to have this service. And it makes satellite way more cost effective for providing these capabilities. And I think that's a huge deal.
And it's Internet 101, right? Because ARPANET was invented precisely by ARPA to have a communication network that would survive a war. Carl.
Yeah, I wanted to sort of bring it back to your critical infrastructure theme, which I think sort of anchored your question. So just as an example, in the United States, we have what's known as the Cybersecurity and Infrastructure Security Agency, or CISA. It's part of the Department of Homeland Security. And they identify 16 areas that they call critical infrastructure. We're forming national strategies to ensure their continuity. Anything from networking to the financial sector to energy, any number of things. So infrastructure, I guess, it's these days, it's not just network, it's cloud as well. But as I like to tell my team, no network, no cloud, right? So interconnecting a distributed cloud really relies on the performance and the availability and the resiliency of the network that underpins it. So one of the things that we've been seeing at SES is that we're starting to see a big rise in the number of applications that we're fulfilling with our fleet is about overlaying a more comprehensive network strategy with satellite resources, especially when we start getting into digital payloads that are very programmable in terms of the amount of bandwidth that can get served and where that can get served. And it can be served over a large geography, which means, the redundancy of gateways or whatnot is always within customers' reach. So all of this really, I think, is starting to come together in terms of assuring critical infrastructure. And I think we're going to see satellite playing more and more of a role in that environment as it becomes more flexible, as it becomes more of a critical lifeline for underpinning the cloud. I just want to kind of bring that perspective to this as well.
A very, very important aspect of things. No network, no cloud. I was going to say, take that, Amazon and Google, but obviously they got the message because they are also building quite a bit of network. The cables get cut all the time also, and they get fixed all the time, and things get rerouted a lot in the telecom infrastructure now. Okay, so let's get back on track, and let me touch on a couple of really cloud-specific cloud industry shop talks, if you will. Edge computing, a very hot topic in that business. The idea is that instead of having one big server hidden under the Alps, which necessarily would be some distance away from the users and so on, that would have advantages and many disadvantages. We'd have a lot of little servers. These days, you cannot buy a hard drive. We've had somebody calling it a private cloud, but more distributed, sort of a halfway house, more distributed. I like to call them server farms because that's what they are, closer to the users. There's a big foot fight in the cloud sector on how many facilities that means, whether it's 1,000 to cover a country to be a reasonable distance from the users, whether it's 100, whether you can do all of the UK with 5 of those facilities. And for you on the panel, there's an even bigger question, which is, are those 5, 100, or 1,000 places all going to have a VSAT on top, which it makes them that many more customers. So is any of this happening? The edge servers, the edge computing aspect of cloud, or is this just a daydream of server merchants who think now that they've sold the big places, they can sell thousands of small ones? Albie.
think again, Sean was beat me to it.
Albie, you go first.
It's
No
yellow,
worries. You go
Ron.
first,
I don't know
Albie.
if there's any meaning to that.
Yeah, I think well, I'm very edge computing is a very exciting topic to me, and I think that edge computing and satellite technology seems to be made for each other, and the reason why is I keep saying the network is the cloud. The network has become the cloud. Instead of you go somewhere via the network to get to the cloud, the network now is the cloud. And depending on where I need those cloud services, I can basically stretch it across the network and put it down where it's required. So I can provide let's say an edge compute environment to a mine in Perth, where at that edge they could run the artificial augmented reality worker assist knowledge base can sit at that server. I could run the worker monitoring and tracking services at that server. And these are all cloud services. These are generic cloud services that I could either run on Microsoft Azure or on AWS C3, or I could run it on a piece of hardware. They look the same, they feel the same, you manage them the same, and it's exactly the same. It's just where it lives. So now being able to push those services down and running those applications, it means I can provide access to that service, let's say the augmented reality, with a private 5G network in milliseconds, instead of trying to get the traffic all the way across whatever fiber network to the mobile network core, and then have it processed there. So to me, edge computing is sort of the next evolution of cloud and making cloud real anywhere on the globe.
And so you can do that, and you do have a wave of customers walking through the door saying, we want to do that, and for that reason, we have X number of additional points we want you to connect, yes?
Exactly. We've put it all in a box, and it is one box that gets shipped with whatever routers and connectors and pre-configured, and it's basically a plug in the Ethernet cable from the new tech modem and fire it up, and you've got a edge server or an edge cloud.
Or even the iDirect modem, Sean.
Yeah, absolutely. So if you look at our kind of ground infrastructure, you have a network management system, you have network processing, you have baseband processing, and then you obviously have our modems, as you just referenced. The reality is, depending upon the size of that gateway and the application or the component, it serves itself to be managed by an edge cloud versus a public cloud versus a private cloud. So to give you an example, an NMS as an example is not very sensitive to latency. And so that's something that can run in a public cloud environment much easier than baseband processing at the edge. That's something that we would envision being run at the edge at the gateway, because it is very processing intensive and very latency intensive at the gateway. And so we see our networks in the future being a combination of customers deploying potentially an NMS in a private or public cloud, doing edge compute for baseband processing, and then looking at things like network processing, IP processing, potentially in a private or in a public cloud. Again, because of the differences in terms of latency requirements, and then also the requirements at different gateways. So you're talking smaller in-country gateways will have different needs than your larger gateways in that example. But we are having those discussions with our customers as we speak. There are some customers who are 100% going down that path, and we're trying to keep pace with them. And then there's other customers who are not there yet, are waiting for a few market leaders like us and some of our larger customers to take that first step before they jump all in terms of moving things towards the edge. So it's an evolving kind of technology migration, but it's something that's going to happen. And again, it's really coming down towards which component in our network is best suited for the edge. Again, baseband processing being one of those that will probably fit well in that environment.
Okay, Carl, and then Stuart.
Yeah, so just a couple of comments from SES on this. We do see more than just a daydream here. We see edge compute really taking hold as distributed cloud, distributed data, distributed applications start becoming more common. Because edge compute really is a logical extension of cloud and virtualization environments, and it really starts offering the ability to flexibly host functions like 5G, for instance, and in different ways depending on the service needs. Private 5G, for instance, can operate at a far smaller scale than a public 5G offering, and that lends itself pretty well to edge hosting. So, in fact, SES has also collaborated with Microsoft recently in support of an architecture that combines MEO satellite connectivity to a private 5G bubble, which was implemented by edge-hosted 5G functions, both core functions and RAN functions. So this model absolutely works, and the industry analysts will tell us that this is going to be a high-growth market, both edge compute, but also something like private 5G, which will rely on that. So, yeah, I think we'll see several hosting and distribution modalities emerging, but distributed compute, including edge compute, I think is going to be a key factor for that.
Oh yeah, the analysts certainly think that edge has a lot to speak for itself, because if you have very latency sensitive applications like 5G, you don't want to have to go all the way to wherever Amazon wants you to go. And if you have, for instance, millions of IoT devices, then it's a lot to carry all the way to the remote server. But sometimes the analysts run a little bit ahead of the game. And Stuart.
Yeah, so everybody sort of touched on this, but I just wanted to kind of go into it a little deeper. The fact is, if you virtualize your signal processing and signal routing infrastructure, that actually becomes part of the edge compute platform that gets deployed. You're actually an integrated piece of that, making, and therefore it just makes it easier for the cloud people deploying these edge compute solutions to use SATCOM, because now, half the terminal is actually running on their platform. And that just changes, again, it improves the economics and it opens up more avenues for the SATCOM industry to be part of the edge compute solution. So I think this is where the virtualization and cloud technology, our adoption of it, makes us a better partner for the cloud industry and for our customers.
Maybe before I let you in, maybe we don't want to have too idyllic a view of the cloud sector. We have an audience question on the cybersecurity aspects of going into the cloud. Now your traffic is going into a third-party facility which you don't control, which we trust is well managed, but the communications inside the cloud very often, I think it was shown, you mentioned it, the public cloud means that the traffic goes on the public internet, which is a place where little children should not be running after 10 o'clock, so to speak. So how do we deal with this, given that SATCOM has for itself that it's ultra secure, walled garden, private enclave, and all that? Suddenly, the traffic can go into strange places. And maybe feel free to weave that into your answer.
Well, someone anticipated my response. I was going to just quickly throw in data sovereignty, because it allows, with edge compute, it allows us to keep whatever we want to at the edge. So if it's an oil exploration organization and they don't want to have their exploration data flying across the ether, then rules can be set up and say, well, use whatever GIS system you want to run, but leave my data on the server or on the edge compute environment that is at my exploration platform. So 100% it now starting to become possible for us to break the application and the data apart, and also decide on different routes for the data and the application. So if we want to use regular connectivity for regular cloud services, but we want to split off certain applications and route that via a dedicated satellite link from the exploration site or the mine to the head office in Geneva, that is possible to do. So it's 100% in that frame where security can now be applied at almost at the lowest level.
And we have, by the way, a couple of additional questions that are somewhat in the same vein. One is on sovereign control of data and networks, which is not possible to do with a VSAT network, but maybe less so with cloud, unless you put you build a server in your own country. Maybe I've answered the question. The other is data protection, GDPR, and how do you see the appetite for defense entities to adopt cloud computing for their activities? I think it's all in the same vein. The security aspects, it's not specific. I'll let you answer, but it's not specific to satellite also, isn't it? It's something anyone who's put his pictures on Instagram has grappled with this already, not to mention if you're an MOD. Who wants to take those questions up? Sovereignty and GDPR. You're not very inspired, are you? So let me throw another audience question at you while you think about those. Like I said, those are not necessarily specific to any mode of transport, like satellite. Someone is asking about the video industry is adopting cloud. There, we do see big broadcasters do what everybody else is doing. Play out is virtualized. They put their archives, their broadcast operations, their editing into private clouds, sometimes into remote public clouds. Carl and Albie in particular, you both, video is a huge market for you. It's changing the way you interact with your broadcasting customers, maybe? Is it or is it just another aspect of dealing with the transformation of telecom, or is there anything special that you have to do for your TV customers in terms of cloud services?
Well, I mean, from my perspective, Stephanie, you've already sort of touched on some of the main things that are happening in terms of cloud adoption for serving content, right? I mean, the play out applications or whatnot. We're seeing a lot of value, and we're working with some of the major cloud service providers to move some of our functions in SES kind of into that environment. And you can probably guess who those are, who have a very strong media pedigree as well. So there's that aspect of it, but kind of, the engineer in me also sort of points out that video is becoming data streams, right? So I think we're starting to leverage common architecture for video delivery as we are with data delivery. So when it comes to scale, when it comes to assurance, when it comes to flexibility of delivering content, I mean, we're starting to be able to build that off of a common infrastructure across video services and data services. And the third thing I kind of point out is the more capability we can put at the edge. So this is back to the concept of edge compute, and whether it's caching or even things like ad insertions or whatnot, that becomes more localized, and with more edge compute folding into SATCOM architectures, we can actually put those functions in the right places. So I do see a fair amount of convergence in terms of the way video is going to be delivered, and some of the capabilities we're talking about in terms of data being delivered as well.
And Sean and then Albie, you both want to jump on that question too.
We always want to jump on the same questions. Yeah, so maybe just
the AI has seen that.
Yeah. So maybe to jump on, just to extend on Carl's answer, completely agree. And what we're also seeing is, you have traditional linear TV and video. A lot of the over-the-top video is becoming a larger opportunity, I think, in the satellite space. We have been working with some ecosystem partners on a solution we call Skyflow, which will enable us to do over-the-top video with our satellite infrastructure in a traditional set-top box. And so, again, I think as we look at the market overall, being able to run these over-the-top applications in a cloud environment is something we're going to expect to see. And again, it will allow us to expand some of the use cases for video and satellite. Today, we have a lot of partners such as SES that leverage it today in our solutions, and we expect that to modify and change as we move to the cloud, especially with the over-the-top being another application.
And over the top, those fateful words have been uttered. No, again, you don't have a choice, because the
market
wants to go. TV is served over the internet now, so get on the train or stay in the station. Albie.
Yeah, so I'm not going to talk over the top. I think we've both Carl and Short has covered that thoroughly. What I do want to mention is that we have a customer that creates content, and some of this content is created in areas that they don't have any really trustworthy connectivity. So what they're doing is using our services and pump that content straight into AWS. So just using AWS Direct Connect, that is cloud basically interconnected with our satellite network, and then pump the content directly into the AWS storage areas.
Okay. Just on the get on the train or stay in the station, that I want to add that my experience is that the satellite industry tends to get on the train through. It's perceived sometimes in the rest of the telecom industry, not to mention the cloud folks, as a bunch of granddaddies with Sputniks who do yesterday's technology. But it's a very flexible community, I have to say, which gets the message when the technology shifts under them and can turn its operations around. I'd say we've quite a bit of agility. Let's get back on a possible cloud problem, because we're talking here about the cloud, like it's a monolithic infrastructure where everything is standardized and the same. Not quite so. The telecom industry itself complains that they have a bunch of different standards, that no two carrier runs its telco cloud systems quite the same way, with the same vendors, the same standards, and so on. Are you in fact facing a bunch of very disparate architectures and customers that it might be difficult to harmonize, or is this not a problem?
So I can answer. I'll give a perspective on that. To me, it's not a problem. It's a challenge that we are working with our customers on, right? So someone mentioned earlier standards, and I think the adoption of standards into satellite is going to absolutely happen. Someone mentioned MEF, the Metro Ethernet Forum, so it abstracts all of the architecture differences between the different networks, and it has a standard way of interfacing, configuring, and managing from a Presto perspective, but also a standard definition of what a service is. What is a ELAN or ELAN service, as an example? And so if we're following those kind of standards, there might be some differences between networks, between providers, whether it's satellite to satellite or satellite to telco. But those MEF type standards will ensure that you have end-to-end service continuity and service configuration, which I think is critical. We haven't talked a lot about 5G, but 5G is another standard that I think drives us towards interoperability across networks in a way that we've never seen before. Not just from a mobility perspective in terms of being able to move our mobility terminals, especially between networks, but also in terms of service definition, again, quality of service, features like network slicing, all those type of things that are built into the 3GPP standards for 5G enable us to abstract a lot of the differences in our networks through standard interfaces from a 5G standard perspective. And so, again, I think standardization helps to abstract a lot of the differences you're describing. And I know STI Direct and a lot of our largest customers are moving in that direction. And again, we think that's good because it expands the market, expands our service offering. If we can offer services not just across satellite networks, satellite providers, but also extend it into wireline traditional telco networks also. It's possible.
And so it would be nice if all the telco clouds were the same, but they're not. But it would be nice, but in the meantime, we can adapt, right? And Carl and Stuart, your take on this.
I think Stuart's hand was up ahead of mine, so.
Oh, thanks. So first off, I agree with everything Sean said. You look at the industry 3 years ago, and definitely 5 years ago, standardization was almost a bad word. Now you see the industry, looking at how do we adopt MEF, how do we adopt 3GPP. It's amazing how fast the industry got behind the Diffie standard for digital IF interoperability. So I think all of that just shows that there's a change in how the industry views standardization, and that's going to help stop the as you develop cloud infrastructure, stop the stovepipes, things like that. The other point I just wanted to make is there's another huge value. Cloud is not just a thing; it's a set of technologies. And one of those technologies is virtualization. And one of the huge advantages of virtualization that comes out of virtualization is that you all of a sudden get the full value of Moore's Law. And just to give you an example of this, Kratos had built software modems running on x86 platforms for years now. We've been selling it into the new space EO market for more than 5 years, and we now offer it into the SATCOM market for E-line services and things like that. And what's really interesting is Intel came out with their latest chipset a couple months ago. So we took our latest modem, moved it over to the new chipset, and saw a 40% improvement in performance of that modem. It took no effort on our part, no effort on our customer's part. It was all based off the R&D of Intel and the other chip manufacturers. And what's really exciting about that is they update those chipsets about every 12 to 18 months. So now we get a steady, as an industry, if we move to virtualized modems and capabilities, we'll get a steady improvement in performance and capability, all based off the R&D of whether it be Intel or other chip manufacturers or cloud manufacturers as they upgrade their hardware platforms. And that's a huge value to our industry. Because if we tie closer, going back to the standards, if we tie ourselves closer to the telecoms industry, their pricing per delivered bit has dropped on average 99% per decade. And so over the last 20 years. So if we tie closer to them, they're going to expect us to live up to the performance improvements they make. And the only way we're going to achieve that is by being able to leverage the R&D of other industries into our products, via the Moore's Law advantages.
And just to be clear, Stuart, those new chipsets, I can avail of them by not by I don't have to replace my modem, right? It happens at this remote.
Yeah, well, it's as Amazon or as AWS or Azure upgrade their processing, you get the performance improvement.
And so you're not selling boxes. This industry was a lot about selling boxes. Now you're selling software. That's what you're saying.
Right. As the industry moves from selling boxes to software, you now all of a sudden get the full advantage of Moore's Law. That's what I'm saying.
That's a huge transformation, obviously. Carl,
yes.
Are you buying software instead of boxes?
We are actually. But I mean, just back to your original question, Stefan. I mean, it's is the stovepiping a problem? Is it getting better? It's like it has historically, yes, that was a problem, right? So SES, kind of is one of Sean's customers. I'm sure he's aware of this, right? I mean, so historically, we procured technology from people like STI Direct and other platform vendors, and they really delivered kind of a very different experience in terms of how we operated them and maybe some of the capabilities they supported across our full customer base that led to operational challenges. And so, for us, this was there's got to be a better way. So I think, for sure, we're making an awful lot of progress as an industry in terms of how do we normalize some of these architectures. I think virtualization is going to be an extremely key inflection point on this. And then I can't overemphasize really some of the comments that have already been made around standardization, whether it's data plane standardization like Diffie, whether it's architectural standardization like 3GPP has given us in terms of an access independent way of delivering service architectures. The more as an industry that we can embrace those things, then I think the operator experience and then by implication, the customer experience, those are going to start becoming more normalized. And I firmly believe, we need to do that as an industry, but I'm certainly seeing an awful lot of traction headed that way. From our perspective, you'll see that SES recently announced alongside Microsoft the formation of what we're calling the SATCOM virtualization program here. And the goal is really to build an industry ecosystem that will collaborate, that will innovate, and will accelerate these sorts of architectures and by implication, really put the full weight behind some of the standards that we think are going to you're going to do away with these stovepipe operational experiences. So agree with a lot of what's been said.
And we're curious to see what will come out of that. I have to say, on standards, to everybody, it's rare when everybody speaks against open standards and standardization, but how many justifications for single source procurements have I seen out of DoD, for instance, that boil down to we have to buy from those guys because it works, or app only works on their software. I'm sure some of that, and sometimes with very big names, some of that I'm sure will survive even in the cloud. In the cloud era, because hey, it's nice to have a captive customer. Once you have that, it's a hard thing to go against. Albie, you had your hand up. You don't have to rebound on that one specifically, but you wanted to touch on the standards thing as well.
Yeah, just very quickly. I mean, in the early days of cloud, it was portability was the big thing, and everybody was touting the portability of their services, and you could move from AWS to a Microsoft and to a Linux or whatever. I mean, now we've reached the point where, I mean, if we look at things such as Docker, I mean, I can run Docker on a 100,000 Rand server, multi-rack server, or I can run Docker on a Raspberry Pi that sits on my drawer. So I mean, we're getting to the point where it's driven standardization and exactly in line with what Carl was saying. At the end of the day, it's the consumer is the winner in this, because you don't have to jump over the fence or make a decision to jump over the fence to go for another platform. It is stick with the standards, and 99% of the market is going to allow you and support you.
And then you can layer your own thing on top, and so still differentiate. Not everybody has to be painted the same color. We still have about 5 minutes. So to the audience at large, you've suddenly become very quiet. It's last calls for questions. Use the Q&R function, please, and we'll patch you in when I can, and I can pretty soon then. But somebody there's a long-suffering question on the 6G standard. We touched upon 5G. Something whose functionalities require the cloud, just because you cannot, for instance, slice traffic in a million places, not at the same time. It all has to be synchronized, and it has to be in a big facility. 6G. That's starting to be discussed. Let's hear about it briefly. Is it just denser 5G? Do we understand what it is? Is it yet another revolution? Are you already kitting up for it, or do we have anything to say yet on that topic? Currently not, but even the standard making body doesn't have a lot to say on 6G. It's an emerging story. It's a little bit everything you want to consider as a 6G. Probably denser. Probably we'll have to buy more equipment and more software, but we'll see. 5G is still far from omnipresent. Okay, let's wrap up.
Actually, Stefan, I guess I didn't want to go completely quiet on that. I mean, from our perspective, we're obviously following what the 6G standards are intending to do. It is going to be about densification. There's probably some other access modalities that are going to be added into it. But really, the comment I was going to make was, it took a long time to sort of zero in on what 5G was going to be. I had my first 5G conversations almost 12 years ago. I think what we're going to see probably is there's going to be a lot of focus from operators, both terrestrial and satellite, to say it's time to start implementing these and really building the business models that are going to drive a return off of 5G. And those business models, by the way, are going to fund things like some of the architectural reworks that need to happen to make the network cloud native in its architecture. So if I were to set it as a dial, I would say that over the next, say, 5 years, there's going to be a lot of execution energy that's placed as compared to something like specifying the future with 6G. And then these things go in cycles, right? And then we'll start to see, I think, a lot of innovation down at the chipset level, at the software level, at the hyperscale level on the development of 6G.
I have to say, even where 5G is deployed and utilized, I think it's a rare network that punches all of the buttons of 5G and uses all of the functionalities. We might at some point reach the limits of what the human brain can possibly require for satisfaction. But let's consider the next 5 or 10 years quickly. I think we have most of what we've discussed was in the future tense already. We've been necessarily a very future-oriented group, but is there anything that we haven't touched upon, for instance, that might become a hot topic in 2 years, 5 years, anything really emergent? Carl, you said we're so busy already implementing what we spent the past 10 years defining. So, but what's in the labs? What's cooking that might preoccupy us at our next webinar next year?
So in general terms, I mean, I think what we're going to see is a lot of adoption of the convergence of ground stations and data centers. So because so many of the functions out of a satellite communications architecture are going to become virtualized, and because so much of the data it's collecting needs, sort of cloud hyperscale analytics and handling, I think we're going to see a natural convergence of data centers and ground stations. And because we're moving more and more towards distributed architectures of the cloud and of the applications that are going to ride over the cloud, and because we're also seeing satellite technology really now starting to embrace the idea of in-country or regional gateways, I think those things are going to align as well. So data centers and ground stations start becoming the same thing. They also start defining a hierarchy of compute, if you will, from hyperscale to regional to national, then ultimately out to edge and to far edge, near edge and far edge. So I think we're going to start seeing a lot of that coming together, which we talked about a lot today. It's one thing to put it on a slide, it's another thing to put it in the field. So
yes.
I think we're going to see an awful lot of that deployment model starting to happen. And the second point, just to reiterate, that's all going to run the risk of creating yet another sort of stovepipe or mixed experience environment unless we really embrace standardization as an industry, which maybe a good topic for next year would be, other than the acronyms or whatnot that we've all been using today, what do the true adoption models look like 1 year, 2 year, 5 years in?
Okay. Closing comments. Apologies to the audience questions that are pouring in now that I've nudged them, but we will answer them offline. That's what we will do. Albie and Sean and Stuart in no particular order.
Right, okay, then I'm going to dive in. So for us, from Intel's perspective, I mean, our unified network strategy is the network of networks, and that is really 3GPP release 17. So the whole non-terrestrial network standards are really driving what our platforms look like. And Stuart and team, I mean, they're working very closely with us in defining and building our software-defined network. For us, it is, as I say, the network of networks. It's got a multi-orbit, whether it's GEO or our planned MEO constellation or HAPS, high-altitude platform systems. All of those will be integrated into a single network, and it will serve the purpose of the customer whatever the customer requires. So if it is a really low latency experience, it will go via HAPS, connecting two spots in a desert. If it's got higher bandwidth requirements, maybe it will go via the MEO constellation.
Albie, now at T plus 4 minutes into the end of a webinar, you're telling us that Intelsat will deploy HAPS?
I did not say we'll deploy HAPS. I said
Okay.
when we deploy, should we deploy HAPS? But yeah, it's not off the cards.
Okay. Yeah, it's part of any vision of the future is what you're saying.
Correct.
Who wants to?
Maybe I'll.
Sure.
Go Stuart.
Thanks. So I was just going to say, we talk about satellites I think the future is that satellites are just going to become network switches, switches on the network. They're not going to be special. They're not going to be unique. They're going to be very expensive and switches and very far away, but they're just switches in the network. And we're going to be just part of the greater telecoms network. And that's why moving to standardization, using the telecom standards is going to be critical for the industry. But the other thing, what I will say is, we hear so much about the promise of the LEO MEO constellations, the Ultra HTS GEO satellites, multi-beam, electronically steered antennas. And, I don't think any of those can reach their full potential without adopting cloud technologies of virtualization, software-defined networking, controllers, things like that. So I think cloud technology is required in the satellite industry for us to reach our full potential of the capabilities that the satellite manufacturers are creating for us. And I think it's time that we just have to take advantage of those technologies so that we can really reach the potential of the industry.
Sean, the last word.
Yes, and I know we're way over time, but I agree with all the other panelists in terms of what we should expect next year and in the near future. The reality is we're talking about it. In many cases, we've already started to deploy some of these technologies with some of our customers, and you're going to see those deployments in more abundance, let's say in 2023, 2024, specifically around distributed networks, which I think Carl was talking about, standardization around 5G, and the interoperability between traditional telco and satellite networks. You've seen some partnerships already be announced between telcos and some of the GEO, MEO, LEO providers. You're going to see more of that. But in addition to the partnerships, you're going to see that true roaming across networks in the very near future. And again, I think that to me is exciting. I think that opens up the market for satellite to be another transport option for these large telcos in a real way that will drive more revenue into our space. And so I'm excited to see it happen and excited to be a part of making it happen.
Okay, so satellites will be a transport option, part of the switching architecture environment and so on, and business as usual in an industry where business is never quite as usual, which keeps transforming. This was a very lively discussion, so gentlemen, and informative. Thank you very much for being with us today. There are a few audience questions that unfortunately, we could not quite patch into the discussion, but be assured that we will now consider them. They will be answered in writing on the GVF website, gvf.org, where you can also watch this recording again, along with the vast collection of previous GVF webinars. And on that note, thank you very much again for being with us today on this joint event of GVF and Connectivity Business News. Please be with us again for our next event, New Space, Will the Bubble Burst? On October 20th at the same time, 3 p.m. UK time, 10 a.m. Eastern Standard Time. Thanks and have a good day.